So, yeah, let us try to understand ANOVA now. So, and I told you ANOVA is also called F table. F statistics. So, sorry, F test. F test. So, when we are about to validate, we shall be looking into the F table. Okay, fine. Now, let's take an example here. Let's say I told you will have multiple samples. So let's say sample 1 is this much. I'll write down the values here. Sample 2 and sample 3. Okay. This kind of a data is given to you. Sample 1, sample 2 and sample 3. Now what happens is let's say 3, 2, 1. Okay, these are the numbers which are given to us. Or just give me a second, let me just change this context. Let me not call them sample. Let me call them school. That's just school 1, so that we can understand it better. This is school number 2, and this is school number 3. And these values which we find, they are basically the marks obtained by children in some test. So let's say this is marks obtained in mathematics. This is marks obtained in physics, and this is marks obtained in, let's say, chemistry. Right? So these are the subjects which we have, and based on that, we have different schools, 3 schools, and we are looking at the performance of students. Okay. So maths average is 3 for school 1. For school 2, average of maths is 5, something like that. Okay. Now, for us, these 3 different schools are what? These are 3 different samples. Okay. These are 3 different samples. So whenever we are performing ANOVA, 2 things are supposed to be calculated. 2 things are supposed to be calculated. Sum of squared distances. What is sum of squared distances? I'll tell you. In ANOVA, let me first mention this point. In ANOVA, you calculate 2 things. You calculate something called sum of squared distances between the samples Okay. So between the sample, you are going to calculate the sum of square distances and sum of within the sample. So between the samples and within the sample, you are supposed to calculate the sum of square distances. For example, if you have these 3 samples, so within means what? Within school 1. You are going to calculate sum of square distances within school 1. Similarly, within school 2, within school 3. Okay, this is what sum of square distance within the sample. Okay, inside sample 1, inside sample 2, inside sample 3. Similarly, when I say sum of square distances between the sample, what would that mean? 3 samples you have. Between means maybe between school 1 and 2, maybe between school 2 and 3, maybe between 1 and 3, something like that. Okay, so between the samples and within the samples, these are the 2 things that we calculate in case of your ANOVA. Okay. Now, before moving ahead, there are few kind of calculations that we should do. And if you people have your calculators with you, maybe your mobile phone will also do. That will help me a lot, because today we shall be doing a lot of calculations. So first of all, let me calculate the mean value. The mean value. So mean value for school 1 is how much? 3 plus 2, 5 plus 1, 6, 6 by 3, 2, then 8 plus 4, 12 by 3, 4, and 5, 6, 11, 11, 7, 18, 18 by 3, 6. So this is the mean value. Yes, X bar. Once we have the mean value calculated, we will calculate something called grand mean. Okay. Grand mean is very simple. The mean values which you have, you will take them 2 plus 4 plus 6 by 3. Okay, so this is 4 plus 2, 6, 6 plus 6, 12, 12 by 3, 4. So grand mean, which is represented by X double bar, is equal to 4. Is it clear? Any doubts?
Understood.
Okay. So mean we have calculated, and then grand mean also we have calculated. Okay. Then after this, what do we do? Here I have mentioned a point which is called sum of square distances. In both these cases, whether it is between the sample or within the sample, we have to calculate something called sum of square distances. So let us see how do we calculate that. Okay. So in that case, what we shall do is we have to consider, before proceeding ahead, we have to consider the shape of this data point, this data set actually. Okay. Is it fine, guys, or should we stop the class today? Okay, let's
continue. I think.
Yeah, you guys can tell me anytime if you feel that you're not able to follow.
Satish, what do you think? I'm okay. I know it's a bit annoying, but you know, I'm okay. You either.
I'm good.
Yeah.
Okay. Anytime if you feel, because it's just a matter of 1 day, will not be delayed as such. So if you feel, you can please tell me. So because I can go on, I don't have any problem, but you people should be able to at least listen to me properly. That's why. So from now on, we shall be writing sum of square distances as SSD. Okay, short form SSD. So this is what? This is SSD between, and this is SSD within. Okay, this is how we represent it. SSD between, sum of square distances between the sample, and sum of square distances within the sample. How do we calculate that? Very simple. You have these individual values 3, 2, 1, 5, 3, 4, 5, 6, 7. What you do is you subtract them. So 3 minus grand mean, that is 4 whole square, plus 2, just consider first few values that you have. Okay, 3, 2, 1. So 3 minus what? Grand mean, which is 4. Then similarly 2 minus grand mean, which is, you'll have some value whole square, plus 1 minus grand mean whole square, plus same thing we will do for this particular column also, and then for this column. Okay, so this much plus 5 minus 4 whole square, where 4 is your grand mean obviously. So 5 minus 4 whole square. At times when they stop, it looks so peaceful. 3 minus 4 whole square plus 4 minus 4 whole square, plus, now coming to column number 3. So again 5 minus 4 whole square plus 6 minus 4 whole square plus 7 minus 4 whole square. Something like that. Okay, so now when we calculate, how much do we have? This much is 3 minus 4, 1, 1 square is 1, 1 plus 2 square is 4, and then 9, 9, 1 minus 4, 9. So just verify from your end, guys, also. Just verify if I'm writing out correctly. Or...
So yeah, I have for school 149, 149. So 1 for maths, physics, chemistry, 149. For school 2 is 110, and school 3 is 149.
149. Okay.
Again, yeah, school 3, yeah. Yes, yeah, 149 for school 3 as well. Satish, did you try? Is that correct? I think it's correct.
No, I did not try. I'm trying.
Yeah, that's right. I've tried. I think it's correct.
Mm-hmm.
So, and then what for the SSD is SSD equals what? SSD is the summation of all of them, is it?
Mm-hmm. So it will be 30. 5 plus 9, then 2, then 5 plus 9. Okay, 30.
Yeah, 30 it is. Yeah.
So sum of square distance, this is how we calculate. And for us, in this example, sum of square distance is 30. Fine. Now, Acha, here I have written M and N. Here I have written M and N, if you can see. M is 3, N is 3. So what is M? M is the number of samples. M is the number of samples. So we have 3 school, 3 sample. So that is why M is equal to 3. And N is the subjects for us. So maths, physics, and chemistry. That is why N is 3. I hope that is clear. So M is 3, even N is 3. Okay. So sum of square distances we have been able to calculate. Okay. Now, when we talk about sum of square distances, here, see, What did I say? With respect to ANOVA, you are supposed to calculate sum of square distances between the sample, and you are supposed to calculate sum of square distances within the sample. Right now, what we have calculated is not any of them. So it's neither sum of square distances between nor anything else, right? So what happens is, when we are talking about, so this is a general value, sum of square distance, general value, this is what we have. We have not done sum of square distance between or within. So in general, this is the value which we get. So one more thing we have to compute, and that is called degree of freedom. Yesterday also we talked about that. So today also we shall be talking about that degree of freedom in general case. Sum of square distance in general case is 30. Degree of freedom in general case is how much? M into n minus 1. This is a formula that you need to remember. M into n minus 1. This is the formula of degree of freedom. Yesterday, the degree of freedom that we saw, what was the formula? Small n minus 1 is sample size minus 1. The sample size was 16, I think. So 16 minus 1 was 15, and that 15 became your degree of freedom. That was very simple. But here, the formula that you will find every time will be kind of tricky. So just try to remember that. So m into n means what? M is 3, n is 3, so 3 into 3, 3 3s are 9, 9 minus 1, 8. So for us, degree of freedom is how much? 8. Okay. So two values we have to remember. Sum of square distance, 30. Degree of freedom, 8. Okay. Now what will happen is, I'm telling you this observation prior to, like before even getting into that output, I'm telling you what you will observe. I told you that we are supposed to calculate SSD between and then SSD within, right? And then what have we done? We have calculated SSD for the entire sample, total number of samples, for total number of subjects we have done. Okay, so in general, we have worked on that aspect. Now what you will observe is, when you add, now listen to this very carefully, when you add sum of square distances between the sample with sum of square distance within the sample, you will find that the output is 30. Okay, you will find that the output is 30, this 30, this 30. Similarly, when you add the degree of freedom of SSD between with SSD within, when you add the degrees of freedom for both of them, you will find that it is equal to 8. This is how in the examination usually, I don't know whether they will give you ANOVA, kind of ANOVA question to solve, because ANOVA is time taking. But even if they give you, this is how you can verify that the values of SSD between and SSD within that you have calculated, whether the values are correct or not. Just add them and see if it is equal to SSD. Okay. So this is a trick. This is a way how you can verify that your kind of whatever you are doing, whatever calculation you are doing, whether it is right or wrong. Okay. So this is a trick which you can remember for future references. But I doubt whether they'll give you an ANOVA or not. But still, you can remember that. So for the total data that we have, we have calculated SSD and we have calculated the degrees of freedom. Now we shall be calculating something called SSD within. Let's calculate SSD within, then we'll get into SSD between. Okay, let us calculate SSD within the samples. So here, how do we do that? Again, simple. Just observe this. You have to calculate within. I told you within means what? Within school 1 or within school 2 or within school 3, like that. Okay, we are not doing anything between them. within the samples only. So let's say if I'm considering sample 1 or school 1, I have to subtract 3 minus its mean, then 2 minus its mean, then 1 minus its mean. Okay, very simple. Formula, there are complicated formulas. If you read ANOVA from any text matter or from any other resources, you will find that they are using a lot of formulas. And when you use a lot of formulas, it becomes extremely difficult to understand the problem. Okay, so I have deliberately tried to remove all the formulas. I have used, like I have emphasized more on concepts so that we can understand ANOVA, because usually this is again an experience which I have from the students. Usually they are not able to understand ANOVA if I use formulas. So that is why I discarded the entire concept of formula. No need to use formulas at all. We'll be understanding them conceptually. Okay. So when we say SSD within the sample, how will we calculate that? I will say SSD within is equal to 3 minus 2. 3 minus 2. Yes. I'm talking about the first sample. So 3 minus 2 whole square plus this one I'm talking about, this one. Yeah. And then your mean is 2. So 3 minus 2 whole square plus 2 minus 2 whole square plus 1 minus 2 whole square. Correct? Then coming to the second sample and its mean. So
5 minus 4
5 minus 4 whole square
plus
3 minus
4 whole square plus 4 minus 4.
4 minus 4 whole square. Correct.
Yeah, goes for the same. 5 minus 6.
This, yeah. Just a second. 5 minus 6
Whole square plus 6 minus 6 whole square, 7 minus 6 whole square.
whatever value we get, that becomes your SSD within. So let's calculate SSD within how much we have. This becomes 0. This becomes 0. This becomes 0. What rest? 2 plus 2. Is it 6? Is it 6? Just verify. Yeah, guys, is it 6?
Yes, 6.
6, no?
Yeah, even I got 6. Yes.
Okay. Divakar, same answer.
So we are looking at which one? Sorry, the school one.
Yeah, so SSD within we have calculated. So final when we add all of them together, what is the answer we are getting? 6 or something else?
6. So we are using the mean of school one, isn't it? The average.
Mean of school 1, we are subtracting it from the individual values.
I'm getting 2.
2 for the first one, na? First sample. Na?
2 for the first one. Yes.
Correct,
First,
that is correct.
2 for the
Then,
school one. Yes.
Then for the next.
You're talking about all the 3, is it?
Addition of all 3 of them. Yeah.
Oh, okay. Sorry. Yeah, just sorry, I haven't done the. I will quickly do it now.
Okay. So I think that will be the answer. Just verify that once what you are done, Divakar. Now, just like the previous case, here also we shall be computing the degree of freedom. Okay.
Yeah, I got 6, yes. Yeah.
6. Yeah. Okay. So here also we shall be computing the degree of freedom. Now here for the entire data that you have, what is the formula of degree of freedom? M into n minus 1. Yes, this one, m into n minus 1. This was the formula of degree of freedom for the entire data. Now when it comes to SSD within, when you are calculating SSD within the sample, then the formula changes. It is m multiplied by n minus 1. Okay. So for us, what will be the value? M is how much? 3. So 3, just a second, 3 into 3 minus 1. Yes. So 2 into 3 is 6. Degree of freedom, how much do we have? 6. Is it clear? Formula has changed. So these formulas are important for you. Every time now, when we compute SSD between also, na, you will observe that the formula will change. Fine. Every time you will observe that the formula for degree of freedom will change. Right now also when we will compute SSD within, sorry, not within the sample, between the sample, when we compute that, you will observe that the formula of degree of freedom will change. But can you people tell me what will be SSD within? We have calculated it is 6. Can you people tell me what will be SSD between? Can you tell me? Without doing any calculations. And degree of freedom. What ideally it should be.
Okay. Can we, so it would be 24, would it? Because we had 30 for the overall general SSD.
Correct.
Minus minus the one we have computed, because you told us that at the end of the day when we add them up, its total should be 30. So I'm on that basis, I'm thinking 24.
Correct. 100% correct. So ideally, I have not yet calculated SSD between, but I think it should be equal to 24. Similarly, degree of freedom, how much?
2.
2. Okay. So we know that this should be the correct answer. Now let us verify. Let us, and once we are able to find that, okay, this is correct, that means the entire calculation which we have done is correct. Yes. So this is how you can use this trick. So let us try doing that. SSD within we have calculated. Let us calculate SSD between the samples. So whatever samples you have, between them, we shall be calculating the SSD values. Acha. Now we are talking about SSD between the sample. That means this is sample, this is another sample, and this is the third sample. So among themselves. Yeah, among themselves we are looking at. So fine. Let us understand how do we calculate SSD between the sample. Again, fairly simple. Okay. So when we calculate SSD between the sample, it's simple. I'll just write it down here. SSD between is equal to 2 minus 4 whole square plus 2 minus 4 whole square. What am I doing? What am I doing?
Using mean between.
Mean and your grand mean. So why am I writing 3 times? I'll be actually writing it one more time, because you have 3 subjects. Because you have n is equal to 3. Because you have n is equal to, because you have n is equal to 3. That is why I will write this 3 times. then the second subtraction between 4 and 4, right? Between 4 and 4. Four minus 4 whole square, how many times? Again, 3 times. Then 6 minus 4, isn't it? 6 minus 4. So individual mean value minus the grand mean. That is what we are doing. And how many times? N number of times. 6 minus 4 whole square plus 6 minus 4 whole square plus 6 minus 4 whole square. Let us calculate this output. Okay, so it's 24. You can verify from your side. It's coming out 24. Because as it is, this entire part we have to neglect. Does not make any sense. So you're just doing addition of this much and this much. So if you do that, you will find it's 24. Okay. So SSD between is 24. And what about degree of freedom? How do we calculate degree of freedom here? What is the formula? It's comparatively easy this time. It is m minus 1. The formula is m minus 1, not n minus 1, it's m minus 1. So what is the value of m? 3. 3 minus 1 is 2. So degree of freedom is 2. Right? Degree of freedom is 2. Now let us see. We told ourselves that, okay, degree of freedom will be 2. So that is what we are getting when we calculate it by the formula. Similarly, we understood that SSD between should be 24, and exactly same answer we are getting also here. So that means whatever we have done is correct. Whatever assumptions, whatever calculations we have made is correct. Right? So is this clear? SSD and all these things. I'm giving you 2 minutes. Just try to recapitulate everything, and then we shall proceed from the beginning till the end. Any doubts if you have? Is it fine?
Yeah.
Okay, so
I'm okay with it.
for you also, is it clear?
Yes, Ashit. It's clear for me. Understood.
Okay, so once we have done this, the values we have calculated, that is fine. But still, we have not done anything with respect to F-test. These are part of F-test, that is fine. But we have not yet calculated F-test. Even I have not given you the formula of F-test till now. Yes. So let us now get into that. We have worked on, we have calculated the building blocks of F-test as such. Okay. We have worked on the building blocks of F-test. And now we shall actually get into the test, the validation test. So, yeah, let us see. So again, it's simple. The formula is very simple for F-test. The way you calculate the elements of the formula is time consuming. So F-test we have, and the formula is SSD between divided by degree of freedom for SSD between whole divided by this entire thing gets divided by SSD within divided by degree of freedom for SSD within. This is the formula. Okay. And that is the reason why we gave so much of time for calculating SSD between, the DF between, SSD within, DF within, all these things. Okay. Another way of representing SSD between by M minus 1 whole divided by SSD within divided by M into N minus 1. This is another way of representation. You can use anything. Here, instead of M minus 1, I have directly written what it means. Similarly, M N minus 1, I have directly written what it means. So whatever suits you, you can use that formula. It does not matter. There is no change in the formula as such. Both of them are same only. Okay. So we have the values here. We have the values here. So that means we will now be able to calculate F test. F test for what? For the data given to us in the question. So from the data given to us in the question, F test will be equal to how much? 24 by 2 whole divided by how much is this? 6, no? 6 by 6 by 6. 6 by 6. SSD within 6 by 6. Yes, 6 by 6. Correct. So this is what we have. So if we calculate it, it will be nothing but 12. Yes. All of you are getting the same value, F test?
Yeah. I got 4.
So F test value that we have got is 12. Fine. And again, this is for what? This is for the data which you have. Okay. Now, in the question, you might have the values for your alpha. You might have values for your alpha. So let us consider value of alpha that we have. Let me first show you the table. Let me first show you the F table. F table is somehow difficult to interpret.
Ash, could you please show me that the board one more time, please?
Yeah, just a second.
This is state between degree of freedom. Yeah, Ash, the second part, like the F test formula, you said no SST between divided by degree of freedom between a whole divided by SST within divided by degree of freedom within, right? To the right hand side of this one, there's other one. What is this actually?
Same thing. Instead of writing degree of freedom between, I have written the formula of degree of freedom between.
Gotcha. Okay.
Because if you look here, this is between the sample, no? Degree of freedom the formula N minus 1. So I've just placed that value. Similarly here also.
Gotcha, got it.
Okay. So let us now see the F table. Okay, let us consider this one only. What do we find here? We find that whether it is your x-axis or y-axis, whether it is your horizontal axis or vertical axis, in both the cases, you have degree of freedom only. Can you see that? On the x-axis or on the horizontal axis also, they are writing degree of freedom 1, and here they are writing degree of freedom 2.
2.
Okay. That means we are only bothered about degree of freedom and not critical value as such. Obviously, the value of critical, this, what do we say? Level of significance will change because you have different tables for that. For example, if alpha is 0.05, you have a different table. If alpha is, let's say, 0.025, you have another table. So definitely it will change. But the idea is we need to emphasize on degree of freedom basically. So for us, degree of freedom 1, degree of freedom 1 will be 2. Okay, that will be equal to 2. That means what is actually your degree of freedom 1? Degree of freedom 1 is actually your degree of freedom for SST
between samples.
between the samples. And what is degree of freedom 2 for us? That is 6.
6.
This one. So degree of freedom 1 is 2 and degree of freedom 2 is 6. So the value which we get is 3.4630. Is this point clear? I'll just make it here in the blackboard. When I say degree of freedom between, I'll say it is degree of freedom 1. And when I say degree of freedom within, I'll say it is degree of freedom 2. Okay. So now when you read the F table, you will be able to remember what is exactly degree of freedom 1 for you and what is exactly degree of freedom 2 for you. Okay. So F of 0.10 is 3.463. Okay. Now, when you have these two values, can you create the bell-shaped curve? Definitely we can. So rejection region starts from which point? Yeah. This is the point from where. This is the point from where your rejection region starts. So I'll just draw one line here, and this entire part which you have, this becomes, or this actually is a part of your rejection region, right? This entire part of your graph is kind of a rejection region, right? And what value of H naught we have calculated? 12. So maybe 12 will be somewhere here, right? 12 will be somewhere here. That means H naught lies inside the rejection region. So can we accept whatever claim the company, the schools would have been making? No.
No.
The hypothesis says that whatever claim the schools might be making, we are not interested in the hypothesis as such. Whatever hypothesis they have, whatever H naught value they have, okay, we're not interested in that. The inference which we make out from this is because H naught is 12 and it lies inside the rejection region, that is why whatever claim the schools are making, that is false, that is wrong. Okay, this is how you solve problems with respect to ANOVA. Just observe this once, whatever we have done from the beginning.
Yeah, Ashutosh, if you don't mind, just want to clarify. So the last calculation that we did, I mean, I understood the table that we discussed, like how we look into the values. So now the F 0.10 equals to 3.463. How did we get these values? I'm stuck there.
Like, acha, just a second, I'll draw that here. Just my pen. So what happens is when you are looking at F table,
Okay.
on the y-axis and on the x-axis, both cases, you will find that degree of freedoms are only mentioned. In the x-axis, you will look for degree of freedom 1.
Yes.
On the y-axis, you will look for degree of freedom 2.
Yeah.
So degree of freedom 1 means degree of freedom
between
or within. Even I got confused. Yeah, so between, yeah, correct.
Between samples, yeah.
Degree of freedom between.
Yeah, between samples. Yeah.
is between, and this is within.
Within. Degree of freedom within. So for us, what is the value of degree of freedom between? 2. And this is how much?
6.
6. So wherever they will intersect, that value becomes your F table value.
Okay. So
If
F
you
test value
check,
is that one.
if you just check it once again from this graph, degree of freedom 1 is 2, degree of freedom 2 is
6 of ja. So 3.46330.
so wherever they are intersecting.
Yeah, 3.46330. Okay.
So same value we have used in our question, and that basically denotes what? The place from where your rejection region starts. And 12 shows the point which is your H0, the value for your H0. From this bell-shaped curve, we can find that the value of H0 lies inside the rejection region, and that is why you cannot accept the claim of the schools.
Got it. Understood. Thank you, Ashish.
So this was ANOVA. And how much time did we take? We started somewhere around 140, I think. So 40 minutes, approximately 40-45 minutes.
Yep.
We gave to understand one question. Fine, no problem. ANOVA is kind of lengthy. It's not difficult. I don't think you people will find it difficult. It's not difficult. The only thing is calculations are more in this case.
Yeah, it will take some time, I believe. More time than the other things.
Yeah. And as far as the formula is concerned, it's very simple. But in order to identify the values for these components, it will take some time. Okay, no problem. It's fine. So shall we do chi-square also today, or shall we stop here?
How long does it take, Ashutosh, for chi-square?
Chi-square, half an hour.
Ooh.
Can we wrap up today and can we do it on Tuesday?
Yeah, I don't mind that at all.
Yeah, it's a bit noisy as well.
Yeah, the other part is, yeah, that's there. But again, this theme's looking, when we look at, we feel like, I need to go through it again, right? I understood the concept, yes, but it looks simple, but again, I need to go through it. Is what I feel.
Definitely, once you practice by yourself, it becomes much more imprinted in your brain. So that's definitely true.
And Ashutosh, I have a question, like these tests, like F test, T test, and the other one, Z test. So where we apply these tests in which scenario? I understood yesterday part, like if it is less than 30, we use T test, and if it is more than 30 is when we use the z-test. So now comes to this f-test. Where do we use this? What is the criteria?
F-test you will use when you have multiple samples. Here also you had 3 samples, school 1,
Yeah.
school 2, school 3.
Okay.
So multiple samples, because in Z-test or T-test or even in chi-square, you will not find multiple samples.
Yeah.
One sample
One sample,
only.
within one sample, the quantity could be more, is what you meant to say.
Correct.
So for this f-test, could you please give 2 more examples, like apart from the schools? In just
I'll try to, either in the class only, I will solve one more question on Tuesday,